Hello again. Welcome to another video. Um, Today I'm going to demonstrate a new technique that I've been playing around with. The reason why I haven't been posting videos is that I've been working on two games and it's been kind of I've been pretty busy. But today I have an interesting video I want to show off. For the past few days I've been playing around with ray tracing, which is a different rendering technique. Let's say if you're using OpenGL, you're using a technique known as rasterization. It's Rasterization is good because it's quick, it's pretty fast to get stuff rendered, but there's a lot of limitations to it. For example, in ray tracing, you might notice that there's shadows and the reflections. It's really easy to do that in ray tracing because ray tracing doesn't look at it looks at the scene as a global kind of context, where rasterization on the other hand looks at the scene through a more local, like for if this was being rendered in rasterization, it would focus on each individual sphere, including this big yellow one, instead of this entire thing. And because of that, I'm trying to think, I'm half asleep right now. This is my third take in this video. Because of that, there's a lot of things you can do relatively easy with ray tracing. For example, because you're focusing on the scene, you can do shadows very easily. You can do reflections very easily. And you don't have to worry about depth testing, because with ray tracing, it's whatever you hit first with a ray. So it sorts everything for you, so you don't have to worry about Z buffering anymore, which is really cool. Now here's the disadvantages of ray tracing versus rasterization. Rasterization is fast. Ray tracing, on the other hand, is very, very slow, which I'm going to demonstrate real quick. Where's that variable? Let's set multi-threaded to false, and we're going to run the application real fast just to demonstrate. Compiled. Excuse me. Alright, pop that up real quick and see if it's... Sorry about this. I'm going to put it right there. Now you should be able to see it. I'm going to put this on the side. Alright. As you can see from the command prompt on the side right there, it's each frame is updated every 1.5 seconds without multi-threaded, which basically means if I move the camera, I'm holding down the button right now, it takes forever for it to update. Let's exit that real quick. There we go. And I'm going to switch that back to multi-threaded. Excuse me. Um, the reason why it's doing that is if we go down to render real quick and look at what it's doing. Skip the multi-threaded part for right now. This is kind of the naive approach for ray tracing. You go through every single pixel on the screen and you calculate a ray. That ray gets pushed to the ray trace method where it will do everything in the scene, including check for collisions. It will compute the position and the hit position of the ray and the normals. It will compute lighting. This right here was a test for refracting. I'm still working on it. But if this was working, it will calculate that too. And reflections, which is, as you might see down here, it's recursive. So, yeah. It's on top of that, like I said before, in the render method, it's doing every single pixel. So, the reason why it's going so slow, it's because the algorithm itself is very, very parallel. Now, this could be addressed with using multi-threaded techniques and using the GPU for rendering. But for right now, I'm just doing CPU-bound ray tracing, so that's why it's kind of a slideshow. Alright, I guess let's demonstrate multi-threaded, which is a little faster, but it's still not fast enough. I'm going to get everything set up. With the multi-threaded stuff, it goes down to half a second, so it's a little bit more responsive. You can actually turn around stuff pretty quick, but it's still a slideshow. So let's look around the scene real quick. Let's go this way. You can rotate the camera using the arrow keys. I decided against using a mouse because it's just not really that responsive. You can go backwards with the S key. You can go forwards with the W key. And you can strafe with S and D, respectively. And let's back up a little bit. You can go up, you can go down with shift, go up in the scene with the space bar, and you can look down with the down arrow key and up with the up arrow key. So some movement here and there. Let's see a little bit more. Yep, this took 3 days to really kind of get it working. And for it running on the CPU, it's not doing too bad, considering that it is ray tracing that I'm doing. Oops, a little too low. Get out of that. And yeah, this is it for this video. I guess I'll catch you all next time. I might actually make this into a little mini series for a bit, because I'm really having some fun with ray tracing, and I want to actually make this into kind of a general purpose ray tracer. So instead of rendering spheres or balls, whatever you want to call them, I can render planes, cubes, and possibility of meshes, which is an interesting topic in its own right. Well, y'all take care, and I'll see you in the next video.